Similar figures. So you were creating similar figures when you were dealing with a dilation. So it was the same shape, just a different size. The symbol for similarity is this right here. So if you were to say that two shapes were similar, you could put that symbol in between and it reads that they are similar. So what does similar mean? It means when two figures have the same shape but are different sizes. So for similar figures, their corresponding angles are congruent, so the angles remain the same size, and the corresponding sides are proportional, which means it might be 2 times bigger, 3 times bigger, half as big, something like that. And we will be dealing with proportions. So let's say we had that triangle ABC is similar, there's our symbol, to triangle DEF. So on this first one, I'm trying to say which sides are corresponding. So AB, side AB, corresponds to side DE. So a couple ways you could do this. Looking at the picture, AB is the first two, DE is the first two. So BC, the second and third letter, match with EF. So those are corresponding. They're going to be proportional. AC, the first and last, corresponds to DF. Now the angles are congruent. They actually keep their size. Angle A is congruent to angle D, first. Angle B is congruent to angle E, second. And angle C is congruent to angle F. Those are both last in the similarity statement. So let's just say that the ratio of the corresponding sides is called a scale factor. So this should sound very familiar because scale factor is also what you used in a dilation. So it's saying something is 2 times bigger, 3 times bigger, 4 times bigger, or so on. Now there's different ways to figure out what the scale factor is because it depends on which triangle you start with. So if I were to ask what is the scale factor of triangle ABC to DEF, let's just take two sides that correspond to each other. So AB are the first two letters, so I'm going to take 8. And DE are the first two letters, so I'm going to take 16. So if I were to write the ratio of ABC to DEF, that would be 8 to 16. So remember, a way to write a ratio is a fraction. My triangle ABC is written first, therefore it is the numerator. Now if I were to reduce that, 8/16 reduces to 1/2. So ABC is half of triangle DEF. Now if I went the other way, and I was trying to find the scale factor of DEF to triangle ABC, using those same sides, that would be 16 to 8, which is 2, because DEF is twice as large as ABC. Now a similarity statement that you could write is triangle ABC is similar to triangle DEF. And if you just double check all of the sides, 10 times 2 is 20, and 18 times 2 is 36. So all of the sides do match up. Okay, if we wanted to find all the missing sides, so we don't have to just have a triangle. We know that quadrilateral ABCD, which is this one right here, is similar to quadrilateral EFGH, which is this one right here. So, I missed one side. I forgot to add that I just put something in the wrong spot. This was a 6, and I believe this one was supposed to be a 7. Okay, so if we look at these two quadrilaterals, there's a couple ways you could do this. You could write a ratio. So I'm going to show you one of the ways to do this. So side AB, which is 3, corresponds to side EF, which is 6. So let's just say I wanted to find the distance from F to G. So I'm going to call that X. I could say that must be the same as BC, which is 5, to X, which is the side that we're missing, okay? Now, there's a couple ways that we could do this. We could think about cross multiplication. We could think about what the structure of the fractions are. Let's just say we cross multiplied. So 3 times x is 3x, and 6 times 5 is 30. And if we divide both sides by 3, we get our missing side is 10. So this is 10. Now, the second way you could have thought of this is just to figure out what is the scale factor. So if I started off with my side 3 on AB, and I wanted to get to a 6, well, how do I do that? That means that my scale factor is a 2. I'm going to take ABC and I'm going to multiply it by 2 to get EFGH. So let's try that with one of the other sides. So I actually found all those sides. If you went from the small to the big, it's times 2. How about with the other direction? That would be divided by 2, because it goes the other direction. You're making it half as small if you were to start with the larger one. So from G to H is 12, and if the smaller quadrilateral is half as size, that means from D to C must be 6. If from E to H is 7, half of that is 3.5. So you could write a ratio, or you can try to find just the scale factor and use it from there. So let's try this one. Let's just say that triangle ABC is similar to triangle DEF. This one I'm going to go from side AC, which is 2, and DF, which is 3. That's not a nice, pretty number, so I'm actually going to use a ratio for this one. So 2 to 3 is the same as, and I'm going to find x first. So my x side corresponds with my 10 side, so x over 10. A couple things to notice. From the same triangle, those two numbers are both in the numerator. So be consistent as to where your numbers go. If I were to cross multiply this, that's 3x equals 20. Divide both sides by 3. And if I were to find 20 divided by 3 as a decimal, it is about 6.7, rounded to the nearest tenths. You could also have left it as 20/30ths or 6 2/3. Any of those would be acceptable. So say we wanted to find y. I'm going to start off with my same ratio of 2 over 3, because that's my side AC to DF. But now I'm trying to find y, and that corresponds with this side, which is 7, so equals 7 over y. So again, I'm going to cross multiply. 7 times 3 is 21. 2 times y is 2y. If I divide both sides by 2, y is going to equal 10.5 or 10.5, or you could have left it as 21 over 2. So you could either try to find the scale factor to find your missing sides, or you can use a proportion. It is up to you.